Hello friends, in this lecture we will look at PCM-TDM system, Pulse Code Modulation, Time Division Multiplexing system. Time Division Multiplexing or TDM is an application of sampling in which signals from multiple sources are multiplexed in time domain and a composite signal is transmitted through the channel. For example, consider two signals M1T and M2T. M1T is sampled and the samples are shown by black cross marks here. M2T is also sampled and the samples are shown by the red dot marks here. Now these samples are mixed because they are sampled offset in time. The sampling rate here assumed to be the same. It can be different, but if the sampling rates are harmonically related for multiple signals, then scheme is easier to implement. So you can see for this example of multiplexing of two signals in time domain, we take a sample from M1T followed by a sample from M2T, then the next sample from M1T, then the next sample from M2T, and so on, such that the time interval between two samples from the same signal is maintained at Ts, and clearly the time gap between two successive samples is reduced, which is T equal to Ts by N, and that is how we effectively utilize the channel for higher amount of time. So we get time efficiency this way. A way to implement such a time division multiplexing system is to use commutators, which are high speed electronic switches. The process is as follows. At the transmitter side, suppose there are n signals M1T, M2T up to MNT are to be time division multiplexed. Before sampling, these signals are passed through low pass filters. These low pass filters acts as anti-aliasing filter because their main job is to limit the high frequency component, which may be undesirable part of the message, and which will ensure that if the sampling is done above the Nyquist rate, the aliasing will not occur. So these are called anti-aliasing filters. Commutator keeps on taking samples from each of the message signal in order, and a composite signal is formed which is transmitted through the channel. At the receiver, another commutator multiplexes these samples and asks them to low pass filters to smoothen the signals, and what we get are the estimates of the transmitted message signal, say M1 head T, M2 head T, and Mn head T. Hopefully these estimates will be very close to the original message signal. Needless to say that the commutators at the transmitter side and the receiver side must be synchronized. An important point to note here is that this scheme shown here for time division multiplexing is common for a PAM-TDM system or PCM-TDM system, whether it is pulse amplitude modulation time division multiplexing system or pulse code modulation time division multiplexing system. The difference is that in pulse amplitude modulation, the pulses after sampling are transmitted directly. In pulse code modulation, however, quantization is also done, and the quantized samples are represented by bits, and what are multiplexed are actually bits. So the interleaving may be on a bit by bit basis or maybe on a byte by byte basis, respectively called bit interleaving or byte interleaving. As far as the transmission bandwidth for a TDM system is concerned, it is n times the bandwidth required for one message signal, assuming that all signals to be multiplexed are band limited to the same frequency. In next couple of sessions, we will solve some problems on time division multiplexing. We'll also take one example in which the bandwidth of all messages are not equal, and we'll try to come up with a strategy for that also. So that's all for this lecture. Thank you.